project is about what intensity of UV rays at different time intervals is best for the eradication of pathogens in the water for commercial activities. What is solar disinfectant? Well, solar disinfectant is a simple method of using the sun to disinfect water over a period of time. How does solar disinfectant actually works? Well, thermal heat heats up the water to a certain temperature and denatures the bonds between the proteins in the pathogens. The UV rays react with the dissolved oxygen to form highly reactive oxygen compounds that are lethal to the pathogens. It caused by fatal DNA damage and destroying the cell walls of the bacteria. Well, why even use solar disinfectant, you may ask? They have different techniques of water disinfectant methods, such as chemical treatment and iodine disinfectant method. Well, the knowledge and resources means to obtain these methods for third world countries might be difficult. My objectives are what intensity of the UV rays eradicates waterborne pathogens. What I'm saying is it the intensity of the UV or is it the total energy that is put into the water to disinfect to eradicate the bacteria in the water? I'll touch a little bit on photoelectric effect, written by a paper written by Einstein. It's simply saying since the intensity of the sunlight changes throughout the year or daily, does the relationship between the intensity and the frequency matters to maximize the germicidal effect of killing off the bacteria? At what optimal level of time needed for the efficient germicidal rate is needed? Here's a simple timeline that I'll be carrying out my experiment. As you see here, a picture with a man doing a solar disinfectant. He's using PET bottles, which is just normal plastic bottles, water bottles, the sunlight, aluminum foil. The aluminum foil is to reflect the sunlight into the water, so more solar energy could be used in the disinfectant, and I'll be using the UVB lamp. My methods: are you thirsty? 1, use a plastic bottle, make sure it's clean. The plastic bottle has to be clean. 2, fill up the plastic bottle 3/4 of the way, just because you want the dissolved oxygen to go throughout the bottle because it's needed. 3, the sunlight with the reflector at the bottom, which is the aluminum foil. And 4, leave it for a certain amount of time, to 6 to 48 hours is needed to disinfect according to the sunlight and the intensity of the sunlight. This is a simple project, but this is the outside project, but we're gonna introduce the laboratory portion of it, which we're gonna use the same method, but instead of putting the water into the sunlight, we're going to use the UVB lamps and the UVA lamps to change the intensity, or change the intensity to see if it's the intensity or the total energy that is used to eradicate the bacteria. Why is solar disinfectant actually important? Well, wars and droughts and epidemic diseases are often found in areas that are lacking access to safe drinking water. As you can see here, a guy in Africa holding a bottle of water. About 4 million people get diarrhea each year, and about 2.5 million die eventually from diseases such as diarrhea. What's the broader impact of this? If we solar energy, if we capitalize on solar energy, solar disinfectant, because the sun is readily available throughout the nation, we could save lives as this one, this little child in Africa.